So this is again several attempts to make that video on solar energy, and we are focusing now on photovoltaic. Same problem than before. I'm the solar man, so I really like to uh, talk about that subject here. So how is photovoltaic working? The principles. So I will just read that one to you here. Solar PV cells convert sunlight directly into electricity. PV stands for photo, light, and voltaic for electricity, whereby sunlight protons free electrons from the common silicon. So the phenomenon, well, that's I think is not that important that it was the 18th century. So production of electricity due to solar radiation and with a layer of silicon. So we have a solar cell. So just to have some principles here. So that's a solar cell. If you put the solar cells together, you will have a module, which is normally the size which you can bind. If you put modules together, then you get an array. Currently on the market, the three dominant one are the monocrystalline, polycrystalline, and what was the other one? Thin film. Okay. Here some more details on well, let's say a more comparison. So the most efficient one is a monocrystalline, but it also has the highest price. The polycrystalline is the one which is, I think, the most application are using the polycrystalline. The thin film is not so much used because of the low efficiency rate. However, it's much cheaper than the other ones, and it's flexible, so it can be actually sprayed on the surface and has some really interesting applications, particularly in the marine environment. Um, then let's say on the other side, there's not much more there. All of them have a 25 years warranty, and they all should have it. There's no moving parts there, so there shouldn't be any problems. There are cheaper products on the market, and there are not the warranty is not for 25 years. So we have three different systems which are used. So we have the standalone DC direct currency, 12 voltage, 24 voltage, 36 voltage. This is a 12 volt one, which you use normally in just a module, a regulator, and then the DC load, most of the time light or DC, the fridges and the backup, or it's a power storage of the battery. The same system, but a little bit bigger, using an AC inverter. So you have a DC load if you want, but you also have an AC load for the TV or fridge or anything else there which is running on AC. And then you have the one which is grid connected. So you have the PV array, you have inverter power and power conditioner to feed it into the grid. Then you have a distribution panel where you can switch your load which you need for your building, and the other one goes to the electricity as a feed in there. And so here you can see some modern application of PV integration into the building envelope, as skylight, as glass facade on that side. So skylight, glass facade, and as a shading device for here. And good. Then I will not go too much in the definition, even if I wrote there some important definition and facts. This is for you. It's not relevant for the course directly, but maybe I put it there because it might be interesting for you to see how much you get actually out of a 1 kilowatt peak panel, which size space you need, and so on. And what I want to mention here is in Mongolia, there is no regulation for being reimbursed feeding PV power into the grid, to my knowledge. Only for large free land solar farms, there's a reimbursement of $0.15 per kilowatt hour. I don't think that they have something here for the urban environment. The same counts a little bit for this standalone system here, which is I think to you familiar if you go on the countryside. You need deep cycle batteries, and this is sizing the battery. So how much batteries do you need for, and that's really depends on your demand, which kind of consumers you have. So this is a kind of, that will give you an idea if you want to have, if you want to calculate your own system and the battery sizing, but not relevant for our course directly. So here now, that's where I'm always get a little bit lost, because that's the heliotrop in Freiburg, Germany, and I will hurry up here. But this is not a, this is actually a plus energy house. It's producing more energy as it consumes, and that's because it puts the additional load of energy into the grid. You can see some features here. So this is a solar array on the top. It's flexible, so it's adjustable. It follows the sun. It's tracing the sun, and this gains actually 30 to 40% more efficiency on the solar panel, because it goes with the sun path. Also, the whole building is turning, but I will come to that later on. Here you see on the side, you see the thermal application of solar hot water. And there are also other applications which you cannot see now, but there's a dry toilet. It's a green water, a gray water treatment. So not toilet water, but all the other ones. Rainwater harvester. You have a geothermal heat exchanger and extreme insulation on the north side. So there should be, yes, that one was, sorry, that wasn't. So there's a motor which is actually moving the whole building, and it's a 120 watt motor. Is tracking the sun. Other things which you have is a triple glass with a xenon filling for the windows. And PV can resist strong winds, as a PV array can be adjusted to the wind and direction. There's no battery storage, I mentioned that before. Excessive load is fed into the grid and is used in the local grid there. Okay, so this is quite interesting. You can also Google that. But I want to focus here on the maintenance issue of photovoltaic. Here you can see that's really difficult to maintain that PV module on the top there, because it's already dirty, because it's also a dirt road. You cannot really access easily the battery storage or cleaning the PV. This one is barbed wired because it's got stolen a couple of times, but also here you can see that's right on the equator. That's how they do it on the equator. The dust is just accumulating on the top of the PV, and nobody can clean it. So also not really the best option there. And of course, you have to think about fire. If there's a fire in the building, or the PV on its own is burning, it's still producing electricity if it's not covered by fumes. So the fire department has to be specialized in for distinguish PV fire, or houses with a PV on the roof. So they have to be covered by a fume that they do not produce any more electricity. I guess that was the last slide. So we are nearly finished with solar energy. There will be another presentation, an online presentation, which I will give you later on. Thank you very much for listening, and have a nice day.